Hello, this is Math 140, talking about Module 7, and we need to talk about functions again, this time operations on them. So there's 4 basic things that we can do with numbers, and we can do the same thing with functions. We've got the 4 basic operations in arithmetic. That would be plus, minus, and multiplication and division. So doing the same thing with functions, the best thing is to jump right in with an example. So here's one function, f of x is x squared. Here's another function, g of x is x plus 2. And let's do that. When we add them, that's going to be a new function. And what does it do? It adds those 2 things together, as in f plus g of x is x squared plus x plus 2. So you could, for example, say the new function f plus g evaluated at the point 3, x is replaced by a 3, you get 9 plus 3 plus 2, whatever that is. And then subtraction is a new function, f minus t that is, and that would be x squared minus x plus 2. Notice that we should put that x plus 2 in a parentheses, otherwise the negative sign only applies to the x and doesn't hit the 2, okay? We've seen that before, and again here it's important. So f minus t of 3 would be 9 minus 3 plus 2. Just go in, replace every x by a 3, and then you can work out what that actually is. That's not the point here. Times f times g is a new function. That will be x squared times x plus 2, and f divided by g is a new function. That would be x squared divided by x plus 2. Questions about the domain might happen. So the domain for f and for g by themselves is just all the real numbers. And when you add them, subtract them, multiply them, nothing bad can happen. It's still going to be all the real numbers. The only time when something can happen is when you divide. You can't have a denominator 0. So we can make a little note that for that last one, the domain would be every number except the negative 2. So in words, all numbers except negative 2. In set builder notation, you can write r minus that single number, negative 2, as a set. That's all just basic arithmetic done with functions. Nothing very exciting happening here. But now we're coming to more interesting things you can do with functions. And the first of those is composition. For composition, it's best to think of every function as something like a machine or a black box that has an input and an output. So here's one black box for f, takes input x, outputs f of x. Another black box takes input x, and it's labeled g, it outputs g of x. And composition is what happens if you take the output of one as input for the other, like this. So we're using f of x as input instead of x. The picture should be this. Let's do it with the examples of the functions that we just had. So f of x is x squared, g of x is x plus 2. What does this really do? It starts with x, which comes out as x squared of the first black box. And then what does g actually do? It adds 2 to the input. So we get x squared plus 2. Here's a general formula for writing this. We're doing g of f of x. That function notation is just perfect for making it clear what is going on. The f of x gets used as input for g. And this function, this new function, is called the composite of g and f. Composite of g and f. Some people write this like this. And you read this as g after f. Because this is weird. You write it with handwriting, first the G, and then you write the F, because we do write from left to right. But when you execute it, you first need to execute the F, and then you're executing the G. So this is weird, and there's no totally safe way out of it. But when you read that notation as G after F, it reminds you in which order are the operations supposed to happen. Let's do another example. Let's use the output of G as input for F. So that would be read as F after G. With parentheses, you write it like this. Use the same functions. What do we get now? We take x plus 2 as input for the function f. And what does f do with it? It squares it. So that's what we get. And both examples together demonstrate something very important. The order of the operations matters. It's not the same thing if you do G first or F first. Why should it be? Okay, so that's composition of two functions. And last bit, there's a couple of homework problems that ask a question like this. Consider a complicated function. How about absolute value of x minus 1 plus 7x? write this function as f after g of x. And there's many possible answers to do this, but I'm going to show you two. So what is a good way to attack this? And the answer is look for parentheses, exponents, things inside a square root or an absolute value. Whenever you see something like this, and obviously here we see that absolute value, then the thing inside it, that's a good candidate for my g, the inside function. Here, I'm choosing g of x is x minus 1. And then I would love to do the f to be the absolute value of x, except that it doesn't quite work because of that pesky 7x that gets added to it at the end. If that hadn't been there, we would be home. We would have done it. So we need to change that a little bit, but we're obviously close. This is hot, okay? So stick with that. We just need to manage to add the 7x somehow, except that we only need it when we were replacing that x by x minus 1. So how can we do that? Plus 7 times x plus 1. Okay, so that's not a try, except I first tried just the absolute value, didn't quite work. And with that correction, it's going to work. So let's try it out. F of g of x is, you replace every x by x minus 1. So you get that. Good. Very close. Plus 7 times x minus 1 plus 1. And that explains why I did that whole thing. I really get absolute value of x minus 1 plus 7x as required. So this can be sometimes tricky, but can also be sometimes easy. If that 7x hadn't been there, it would have been an easy example. Okay, so that's the deal, the questions that can happen for composition.